Indonesia, to the Honorable First Speaker, Ms. Cherlina Helena Purnamasari Panjaitan, as a lecturer, Information Engineering Department from STEKOM University, Indonesia, to the Honorable Second Speaker, Mr. Abhinav Kumar, as a Program Lead Software Development, Chandigarh College of Engineering from India, and the last speaker, Professor Danilo Strugarevic, as an assistant PhD candidate from ABK University, Serbia. And last but not least, also to the honorable guests and audience today. Okay, before we begin, I have a few housekeeping notes here. Today's session is being live streamed on the Universitas Tekom YouTube channel. And for today event, we will start with Indonesia National Anthem and continue with the main event presentation by our special guest today and continue the Q&A session. Take a picture for documentation and last time is closing. Okay, right now we will start with Indonesia National Anthem for the Mr. Abdullah. You can start this session. Thank you. Okay, thank you. And we will go to the main event for our audience. If you have any question for the speaker, please add them to the chat and we'll be able to answer some of the during the Q&A session after the presentation. And today is presenter will have about around 30 minutes for the time duration presentation. Now let please welcome our first presenter, Ms. Cherlina Helena Purnamasari from STEKOM University. The time is yours. Thank you.
Check. Thank you, Novita. Fine. Good afternoon, everyone. To the esteemed rector of STEKOM University, Dr. Teguh Santoso, and to the organizing committee of today's international webinar. Thank you for giving me the opportunity to speak at this webinar. And to the distinguished speakers of today's webinar, good afternoon. Let me introduce myself. My name is Cherlina. I am a lecturer in Informatics Engineering at M.Kom University, Indonesia, and I am currently pursuing a doctoral degree in computer science. It's a pleasure for me to be a speaker in this international webinar, and today I will discuss about cloud computing and DevOps transformation in modern infrastructure. I will share my presentation first. Okay, I hope my presentation is available in your laptop. Okay, today we will discuss the symbiotic relationship between two of the greatest forces in technological evolution, both computing and development operation. Uh, the the big title is cloud computing and DevOps transformation in modern infrastructure. We will talk about the theory and the practical blueprint, real world, and maybe some case studies about these two technology.
Bu,
Yeah.
oh ya tadi ketutupan.
Oh,
Yeah.
okay. This is clear now.
Yes,
Okay, what about now?
sekarang ketutupan.
Oh, if this okay.
Yes,
So
everything is perfect.
okay. First we talk about cloud computing. Cloud computing refers to the on-demand delivery of computing services, including servers, storage, database, networking, software, analytics, and intelligence over the internet, or we can say the cloud. Users access the service like server, storage, database, networking, software, analytics, and intelligence, all of the service from a third-party provider such as a AWS, Azure, or Google Cloud on a pay-as-you-go basis and benefiting significantly from enhanced scalability, rapid information, flexibility, and also cost efficiency. And then the cloud computing have many service model, and we can say the cloud stacks. The first is infrastructure as a service, and then platform as a service, and then software as a service. Uh, let us talk about the first one, infrastructure as a service. This model is skin to this model is like we skin to leasing bare land in digital world. You are provided with virtual machine, storage, and networking resources. And then you remain responsible for managing the operating system, runtime environment, and application. So this one is provides fundamental computing infrastructure over the internet, including virtual servers, networking, storage, and operating system. The the user control is the user manage the operating system, applications, and middleware, offering maximum flexibility. The typical use case are hosting scalable websites, developing complex applications, or high-capacity data storage. For example, Amazon Web Service or AWS, EC2, Microsoft Azure Virtual Machine. They are the example for the service that we can say infrastructure as a service in the cloud computing. And then another service model of the cloud computing is platform as a service. So the analogy for platform as a service is platform as a service is comparable to renting a pre-built house. So you focus solely on your application code, and then the platform manages the underlying servers, operating system, and middleware for you. So the platform as a service is delivers a complete hardware and software environment for building, testing, and deploying applications without the need to manage the underlying infrastructure. About the user control is the user manage the application and data while the provider handles the operating system, hardware, and runtime environment. Typical use cases are rapid application development and deployment or eliminating concern about server stalling. The example are AWS Elastic Beanstalk and then Google App Engine. And then from Microsoft is Microsoft Azure App Service. So there are the tools or applications that give service model platform as a service. And then the another service model is software as a service. So software as a service is this model is best described as renting a hotel room. So the analogy is like you rent a hotel room, you simply consume and use the finalized software application. Software as a service is offers fully functional software applications that are hosted and managed entirely by the service provider, accessible via a web browser or mobile application. Okay. Uh, Sorry. User control. Users simply utilize the software. The provider manage everything else, like application, data, runtime, operation system, and infrastructure. And the typical use case are email service, collaboration tools, and customer relationship management or CRM system. For example, are Google Workspace like Gmail, Docs, and then Microsoft 365, Word, Excel, and then Salesforce. So they are the application or tools that give the software as a service, the service model from cloud computing. And then the last one is function as a service. Function as a service provides an event-driven execution model. So code is packaged as individual stateless functions that run only in direct response to specific trigger or event, like uh, HTTP request, a file upload to storage, or a message arrival in a queue. And then the cloud provider automatically handles all underlying infrastructure concerns, including server provisioning, patch management, operating system maintenance, and resource sharing. And the developers are free to focus exclusively on writing business logic. Function as a service is the specific compute service category under the serverless umbrella. For example, AWS Lambda, Azure Function, and from Google is Google Cloud Function. So there are four service model from cloud computing. So what about DevOps or development and operation? DevOps, the term DevOps is a portmanteau of the two primary functions it integrates. Two words and two primary functions. The first is development and operation. DevOps represents a cultural transformation that leverages automation, collaboration, and continuous feedback loops to unify development and operations, resulting in faster, more reliable software delivery. Okay. Uh, so cloud computing is widely regarded the best enabler or facilitator for DevOps, as it provides the technical and cultural foundation that align perfectly with DevOps principles. However, it is important to that DevOps can be implemented without the cloud, but the cloud makes it significantly easier, faster, and more cost-effective. But we have to know how does the cloud facilitate DevOps? How does the cloud computing facilitate DevOps? There are five key DevOps practice. The first one is continuous integration, the practice where developers regularly merge their code changes into a central repository. Each merge is immediately followed by automated build and testing. So the repository is in the cloud. And then the second key is continuous delivery, an extension of CI or continuous integration, where code changes that have successfully passed automated testing are automatically prepared and made ready for release to the production environment. And then infrastructure as code, managing and provisioning infrastructure such as networks, storage, and servers using codified files rather than manual process, ensuring consistency and repeatability. And then monitoring and logging, utilizing tools to collect and analyze metrics from the entire application lifecycle from development to production to ensure optimal performance and reliability. And then the last one is microservices, architecting applications as a collection of smaller, independently deployable services which significantly enhance agility and scalability. Okay, so the powerful symbiotic between cloud computing and DevOps. The symbiotic power where cloud meets DevOps. So the The code platform provides the essential tools and infrastructure that make modern DevOps practice feasible and efficient. The first one is infrastructure as code, like we talked before. The code enables scripting tools like Terraform to provision servers, networks, and database in minutes. This feat is virtually impossible to achieve with traditional physical data centers or brands. And then we have automated CI or CD. The code provides powerful, tightly integrated native pipeline service such as AWS Code Pipeline or Azure DevOps. Build and deployment process can be automated instantly without the need to set up custom CI or CD servers. And then scalability and elasticity. DevOps relies on fast, frequent testing. The cloud allows teams to scale up and scale down testing environments on demand, leading to significant cost savings. And then microservice and containers. Manage cloud service like Amazon X or Google HKE eliminate the heavy complexity of Kubernetes cluster management, freeing DevOps teams to focus on application development speed, not infrastructure overhead. And then observability or monitoring. The cloud provides robust built-in tools such as CloudWatch or Google Cloud Operations for comprehensive logging, monitoring, and application tracing with minimal configuration. Okay. Uh, and then the powerful symbiosis between cloud computing and DevOps also make DevOps maximize the value of cloud infrastructure. Uh, what it, uh, what the what the value of the cloud investment like cost efficiency. So through automation and stringent monitoring for DevOps principles, teams ensure that expensive cloud resources are not running when idle. And then the cloud pay-as-you-go pricing model is fully leveraged by DevOps automation. And then rapid delivery, high ROI. DevOps ensures that new features and bug fixes are delivered to customers extremely quickly, which means a higher return on investment or ROI from the cloud infrastructure you are paying for. And then integrated security, Dev Security Ops. So DevOps practice integrate security, Dev Security Ops directly into the automated deployment pipeline, utilizing existing cloud security tools, thus reducing risk without slowing down the delivery process. Okay, so for this slide, we discuss about the case study. For example, the case of the e-commerce retailer. The name of the e-commerce retailer is Fast Card. This is just example for the case study. So this case study illustrates the business impact of adopting DevOps and cloud technology. We have the initial situation here. Release frequency is a large-scale release occur only twice per year. And then organizational structure, development and operation teams were siloed and frequently clashed during deployment cycle. And then stability issue, the e-commerce site frequently experienced several unplanned downtime, particularly during major promotional events. This is, for example, the initial situation. And then, we say that this company subsequently underwent a transformation by adopting DevOps and cloud technology. So they have the transformation here when the company adopting DevOps and cloud technology, the company execute a comprehensive modernization strategy. Like first is cloud migration. They migrated their entire platform to AWS or Amazon Web Services. And then for the process implementation, they implemented a full CI/CD, continuous integration or continuous delivery pipeline using Jenkins. And then for the infrastructure, all infrastructure components were defined and managed as code using Terraform. This is infrastructure as code. So this transformation result in several measure outcomes such as release frequency before DevOps or cloud. For example, they only twice per year. So the release frequency only twice per year. And then after transformation, weekly release. And then what about the stability, the downtime? Before DevOps and cloud, frequent unplanned incidents. But after transformation, unplanned downtime reduced by 90%. And then about the cost, before DevOps and cloud, high fixed infrastructure costs. After transformation, infrastructure spending reduced by 30%. The improvement about the cost achieved through intelligent auto scaling and the automatic decommissioning of idle servers. And the improvement about stability downtime due to automated testing and rapid rollback capability. So this is the case study when some company transform adopting DevOps and cloud. Okay, so this is the emerging trends shaping the cloud and DevOps landscape. The technology landscape is continually evolving. The following trends are set to further accelerate the transformation. The first trend is GitOps. Git as a single source of truth. Use Git repository to define and manage infrastructure configuration. And then the automation is tools like Argo CD automatically synchronize the desired state in Git with the actual cluster state, Kubernetes. And then the benefit is bring DevOps speed and auditability directly to cloud native applications. And then we have AI ops, AI operation and machine learning operation. AI ops uses machine learning to analyze monitoring data, predict value proactively, and automate incident response. The applications or tools are services from Splunk, Dynatrace, or cloud platform from Azure Sentinel. And then uh, machine learning ops applies DevOps principle, CI or CD monitoring, specifically to manage, deploy, and monitoring AI, ML models reliably and quickly. The tools are Uberflow and StakeMaker from Amazon. And then a smarter FinOps. The goal is to transform cost management from reactive to proactive and automated. The method is moves beyond simple tagging, use AI-driven optimization to identify and help wasted resources or schedule workload based on lowest cost prices. The tools or the application is Cloudability, Cost Explorer Service from Amazon, and other cloud cost management tools. And then the another trend is edge computing. Edge computing is computing power moved from centralized data center to the edge of the network or near the user or device. Drivers is too essential for low latency applications powered by 4G and IoT. For example, AWS Outposts and Azure Edge Zones deliver core cloud capabilities locally. The technology is AWS Outposts from Amazon and Azure Edge Zone. Okay, that's all the emerging trends shaping the code and DevOps landscape. And then to summarize our discussion, code is the enable or the stage providing infinite flexibility and scalable resource. DevOps is the methodology or the director ensuring those resources are utilized efficiently, collaboratively, and automatically. Cloud service model offer varying degree of abstraction, allowing business to select the precise level of operational control needed, and then full TI or CD adoption facilitated by cloud transform release frequency from monthly or yearly to weekly or even daily, as demonstrated in the first part case study that before we discussed. And then AIZ practice and auto scaling reduce unplanned downtime and significantly lower infrastructure costs through intelligent resource management or smarter FinOps. Okay, that's all my presentation. Thank you for your attention. We are now ready to take your question.
Okay, thank you so much for your presentation, Miss Cherlina. And we have three questions from participant. For our first question, could you please explain how cloud computing has changed the way modern infrastructure is designed and managed? Thank you.
how cloud computing has changed the way modern infrastructure is designed and okay. Uh, okay. The shift to cloud computing has fundamentally re-architected how modern infrastructure is designed and managed, moving from a hardware-centric model to a software-defined or API-driven one. Uh, for example, financial model, the traditional infrastructure is maybe large upfront investment in hardware. And then if you want to change to modern cloud infrastructure, you have to use operational expenditure or the application or the service in the cloud infrastructure, you can pay as you go or consumption based billing. And then, for example, the scalability in the traditional infrastructure, you do static or manual over provisioning for big load, slow to scale. And then if you move to modern cloud infrastructure, uh, resource scale up down automatically in minutes or maybe in seconds. So you no longer buy fixed hardware, you just run flexible dynamic capacity in the cloud service. This flexibility is the foundation of modern system design. Uh, and then shift to cloud native architecture. So modern infrastructure design favor architecture that maximize cloud benefit, like microservice that we already talked before, and serverless computing that utilizing managed service where the underlying infrastructure is completely abstract away, allowing developers to focus purely on code, like Amazon Lambda or Azure function. Okay, that's the first question. And then the second question is, I'm sorry, the chat is disappeared. Kinan, what are the main difference between traditional IT infrastructure and cloud-based infrastructure? The difference between traditional IT infrastructure and cloud-based infrastructure. The key difference is first financial model. Okay. The traditional IT, like I said before, is investment a lot in hardware, data centers, and software license. And the cloud-based infrastructure, you can pay as you go, just utility model. Pay only for resource consume. So you rent cloud based on unit, like the uh, you just pick for service model that cloud have, and then you just run it or use it, and then pay as you go utility model. And then for scalability and capacity, the traditional IT is over provisioning to handle peak load. Scaling requires buying and installing new physical hardware. It is slow and somehow very expensive. And then if you use cloud-based infrastructure, this is elastic and or demand. So resource can be scaled up or down almost instantly and automatically auto-scaling based on real-time demand. And then about the resource management, the traditional IT is full ownership. The organization is responsible for all layers, like physical security, hardware maintenance, patching, power, and cooling. In the cloud-based infrastructure, you share responsibility model. The cloud provider manages the underlying infrastructure, like hardware, facilities, core network. And then the user just manage application, data, and security configuration. And then the last one is for about deployment kit. The traditional IT may be the time required to procure, install, configure, and secure new hardware is quite long. But if you use cloud-based infrastructure, this is a very fast because all of unit is available in the application. You just need to using all of the service resource are provisioned programmatically using infrastructure as code. So that's all the difference between traditional IT infrastructure and cloud-based infrastructure. And then the last question, how does DevOps how does DevOps culture support faster and more reliable software delivery in cloud environment? Okay, this is actually a core concept that defines the modern software industry. DevOps culture is the essential accelerator that enables high quality, reliable software delivery in a cloud environment. Because the support is provided by fundamentally changing how teams collaborate, automate, and learn. The team in DevOps is collaboration and shared responsibility. And then they use cloud to automation and CI and CD, continuous integration and continuous delivery. And then they fast feedback loops. Reliability is not just about avoiding failure, it's about recovering quickly. So the DevOps culture is how to fast feedback loops. So DevOps cultures combines the agile principle of fast iteration with the cloud capability of automation and elasticity. This synergy is what allows organizations to achieve high-performing status characterized by high deployment frequency and very low mean time to recovery. Okay, that's all my answer. Hope you can understand and give the more insight for you all guys. Thank you, and I'll give the time back to Novi. Thank you very much.
Yeah, thank you so much for your presentation, Miss Cherlina, and for your answer. And we will go to the second speaker for Mr. Abhinav as a program lead software development from Chandigarh College of Engineering. The time is yours. Thank you.
Hi, yeah, good afternoon to everyone. Am I audible to everyone?
Yeah, sure.
Okay, fine. So let's start with the things. Let me just share my screen with you and then we'll move forward. Okay, just give me a second. Just give me a second. Let me just look at my. I believe this is visible to everyone.
Yeah, sure.
Okay, fine. Just go through things. Just a second. Okay, I mean, I'm having some problem with the sharing the screen. Let me just fix this. Forward. Okay, let's put it here. Um, This is the whole concept. Okay, now, so I hope this is visible to everyone. Everyone can see the content, right? And so, yeah, hi, my name is Abhinav, and I work as a program lead in CGC University back in India. So, today's topic is basically the cloud computing and DevOps transformation in modern infrastructure, right? So, our focus area would be on the cloud, the different kind of cloud vendors that Ms. Cherlina has already mentioned in her presentation. And we also talk about the concept of DevOps, how this DevOps thing has transformed the whole cloud computing infrastructure. And we also talk about the Kubernetes, which is basically a backbone for all the DevOps operations, actually, right? So, so let's just I just wanted to yeah. So I just wanted to narrate a particular story that how this whole cloud computing thing has evolved over the years, right? So if you go back maybe 15 to 20 years, right? So if any particular organization has to deploy a particular application, then it the first thing it has to do is to buy the physical servers, right? So this was the first thing that the whole deployment of the application has started his journey, actually, right? So back in 15, 20 years, if any particular organization has to deploy an application over the internet, then it has to buy this physical servers, right? And these physical servers, it required a lot of capital investment because you need to buy the hell lot of hardwares, and then you need to buy the operating systems, and then the other configurations as well to work with physical servers. So it required a significant amount of capital investment, right? And then once you get the physical servers, then you have to manually install those servers. Like, I mean, what are the installation that you have to do? You have to install the operating systems. You have to install other dependencies and the other resources over the physical servers so that your application can run on these physical servers, right? So so, and because of this whole thing, manual installation and buying the physical servers from the third party vendors, it makes the whole deployment cycles very slow. So once, so before 15 to 20 years before now, if any particular application needs around weeks or months to deploy on the physical servers, because you need to buy those servers, you need to manually install the configurations over those servers, and then the application would be deployed in those physical servers. So that makes the whole process very slow, risky, and error prone because we manually install everything. So we humans tend to create some problems and to create some mistakes. So because of those mistakes, the whole deployment process of the application over the physical servers become error prone, actually, right? And if you want to scale up or scale down the deployment, like for example, if you have a lot of traffic over your application, then you need to scale up your application, actually. And for scaling up the application, you need to buy a new hardware. And then again, it requires a lot of capital investment. Then you have to manually install everything on the new hardware, and then it takes weeks or months of delay to scale up your application. Right. So these were some, and the most important part is if your physical server got failed, if any particular hardware got crashed, then again, your application would not be able to deploy, would not be able to see over the internet until unless you fix that issue. And fixing that issue back in 10, 15 years ago, it was just another fight, actually, right? So this is how we started with the cloud computing, actually. So this was the first thing that we started deploying the application over the internet with the help of physical servers. And these were some problems. These were some the consequences that we faced by using one physical server to deploy the application. So there was some tagline, back in 10, 15 years ago, that once the application was deployed on physical server, teams hoped nothing would break, right? So if anything would break, then it takes weeks and months to solve that particular problem, and then the deployment of the application got delayed. Then it comes the era of virtualization, right? And the virtualization is actually a one major shift in the cloud computing part. And we also use virtualization nowadays as well. Like, for example, using different machines and using different operating systems in one hardware. So this is the virtualization. So one server become many, right? So if you're using one server and then install many operating system and many virtual machines on that particular server, and then you can use all these virtual machines at one server. So this is actually the virtualization. So what we do, so the virtual machine means that now you don't need to use a single physical server, right? Now you can run multiple virtual machines on a server, and then you can use these virtual machines to deploy your applications. So for example, if you want to scale up your application, then back in 15 years now, if you go to this here, if you want to scale up your application, then you need to buy the new hardware. But in the era of virtualization, you don't need to buy the new hardware. What you can do is you can just deploy, you can just deploy one virtual machine in your physical server, and then use that virtual machine to scale up your application. So each VM and every virtual machine has its own operating system, application, and resources. So every virtual machines you need to install. Like for example, if I want to use Linux operating system and Windows operating system and Mac operating system in my physical server, then again I have to install three different virtual machines with three different operating system that has different applications and resources. So every virtual machine has its own operating system and applications as well. And then how did you install all these virtual machines in the physical server with the help of hypervisors. So this hypervisors is actually a particular software or the third vendor tools that helps you to install different virtual machines in a single server. Like for example, VMware, Hyper-V, Zen. These are all the hypervisors that can be used to install different virtual machines in a single physical server. I will give you one example that how can we do this actually later on. Then and what it does actually, then you reduce the need to buy new physical server. And I told you, and I've explained you this as well, that if you want to scale up your application, then you don't need to buy a new physical server. You can use these virtual machines to scale up your application and to increase the traffic over the application. And it also improves isolation between application, because every virtual machine is independent of the is independent actually. So they don't know. So your one virtual machine would not know what you are doing with another virtual machine. So there is a significant isolation between each and every virtual machine that you are using in your physical server actually. But definitely it's still a challenge, right? I mean, it's okay that you are using multiple virtual machines, but still you are doing everything manually. You are deploying your application manually over those virtual machines. So that takes a lot of time. And scaling required VM provisioning and configuration. So if you want to scale up your application, definitely you don't need to buy another physical machine. You can use virtual machine, but you need to provision that virtual machine as well. You need to make that virtual machine to scale up the application. You need to deploy different configurations. You need to deploy different kind of resources over those virtual machines, so that your application can work on those things, right? And operations remain complex and slow, definitely, right? So virtualization, gives you that you don't need to buy other physical servers to scale up your application or to scale down your application, but still you have to deploy the whole application in those virtual machines manually, right? And the whole concept of DevOps and cloud computing is to make the things automated, right? Make the things automated, but still you were doing manually things in the era of virtualization. So one example of virtualization is basically, I can show it to you. If you can see here, let me know if you can see this example that I can show it to you. Like for example, um, like for example, this. So this is the hypervisor that I have installed in my machine, right? So this is the hypervisor, and this hypervisor has two different operating systems. One is the Kali, Linux Kali virtual machine, and the other one is the Ubuntu, right? So I'm using Mac operating system. So this is my one physical server, right? In that physical server, I can install two different virtual machines with the help of hypervisor, right? So this is the hypervisor that I'm using. And with these hypervisor, I can install multiple virtual machines in my Mac operating system. Right. So this is the concept of the virtualization. So this is what virtualization does actually. But in virtualization, still you have to do the things manually. And then we need to get rid of this manual thing in the era of DevOps and cloud computing actually. So let me just close this window, right? And then we move forward again. Uh, okay, fine. So, so yeah, so these were some challenges that we faced during the virtualization era. And then it comes to the cloud computing part, right? So what exactly is the cloud computing? So the tagline of cloud computing is to rent infrastructure like electricity, like for example, we rent the electricity from the government. In the same way, we rent the whole infrastructure from the third party vendors actually. And this is called cloud computing. So instead of buying the new physical servers or instead of installing the new virtual machines in your physical server, what we do is we rent those virtual machines, we rent those physical servers from the third party vendors, right? And then we can just use those infrastructure, right? So organizations, what they stopped buying servers. We don't need to buy the servers anymore in the era of cloud computing. And then they started renting the infrastructure. Infrastructure means the physical servers, the resources, the storage mediums, or maybe the services. All these are the infrastructure part. So this infrastructure, they can rent it from the third party vendor. And what are those cloud providers? These are called the cloud providers, right? And for example, AWS, Azure, GCP, these are the cloud providers. Amazon Web Services, Microsoft Azure, and Google Cloud Provider. So these are some cloud providers by which you can rent the whole infrastructure and then you can use it on demand. So what they can do is they can provide you the storage, networks, services, and the other configurations as well, right? Then resources can be created or removed in minutes. Yes, but you can go to the AWS website, you can go to the Azure website, and you can just create your own infrastructure. You can create your own infrastructure. You can create your own physical server as well, and that you can use to deploy your application. Then now, if you go back in 10, 15 years ago, right? So you had to buy the physical server and that involved the capital expenditure. Now in the era of cloud computing, it converts it into you can use the operational expenditure, right? So this is the operational expenditure, right? For example, pay only what you use. So if you're using storage, from the AWS, or if you're using networking from the AWS, then you have to pay only those resources as well, right? So that is the operational expenditure, right? So we have shifted from capital expenditure to the operational expenditure in the era of cloud computing. Now, what are the different kind of models that you can introduce, right? So there's one question here. What are the key challenges? So there's one question I can just take one question at a time. What are the key challenges organizations face when transitioning from on-premise systems to cloud infrastructure? See, uh, the main key challenge is basically that you need to know a lot of things about the cloud infrastructure. So if you are renting some information, if you are renting some resources, like for example, if you are renting the electricity from the government, then you need to understand the whole, that how can you use that rented electricity at your home, right? What are the what are the important resources that you can use with these with the electricity? So this was the key challenge for the organization, that yes, of course, we are renting some physical server from the cloud infrastructure, from the cloud provider, but how can we use that infrastructure? How can we use significantly those infrastructure to to deploy our application more significantly, so that I can pay less but can use more services? So this was the one research, and this was the one key challenge that the organization had to face, transitioning from on-premise system to cloud infrastructure, right? And then they had to, and for that particular thing, they had to they had to hire some experts, so that they can create a whole architecture, that this is how we can use this rented cloud infrastructure to deploy our application, right? And this is way, this is in the similar way, the DevOps position, the DevSecOps position comes into action, right? And we will talk about this in our next slides actually. So the service model introduced by the cloud computing is basically what? Is basically IaaS, right? Information, right? And PaaS and SaaS. Ms. Cherlina has already been explained all these service models in our presentation, so I won't be digging deep into these. But yeah, these are some that is being provided by the cloud providers like AWS, Microsoft Azure, GCP, and according to our requirement, according to the organization's requirement, you can use these services. So if you need virtual machines, right, storage, networks, then you can use IaaS service. If you want databases, right, like for example, you need to store some information in the database, but you don't want to create the database. You want to rent it from the cloud providers, then you have to use PaaS service. And the next one is the SaaS. So there are some ready to use services that you can directly use in these models actually. So this is the era of cloud computing, that you don't need to buy the physical server, you don't need to install the virtual machines in your local machine or in your server. You can just rent the whole server from the cloud providers, and then use those services, and then pay only what you use. So this was the whole concept of the cloud computing. Now it introduces, right? I told you that in cloud computing, what you are doing is you are renting the infrastructure. Now, how can you manage that infrastructure? How do you manage that infrastructure so that you have to pay less? With this scenario, we introduce DevOps. So this is the DevOps thing actually, right? So DevOps is basically the collaboration between the developers and the operation teams. Developers who develop the whole application, operations who manages that application, who manages the scaling of that application over the internet. That is the concept of operations. So it was a collaboration between the developers and the operations, so that we can develop the application and also deploy that application on the rented infrastructure together, right? So that is why this term DevOps thing comes into action. Now, what were the problems before DevOps actually, right? So before DevOps position, developers wrote code. They had to write the code actually, and then they handed it to the operation team. So there was two different teams. There were two different teams. One is the developers, and the second one is the operations. Okay, developers they write the code to develop the application, and then once they develop the application, they hand it over to the operation team. Now the operation team had to use that rented infrastructure to deploy that application. ठीक है ना? Then what was the problem with that? The problem is that operations focused on stability, developers focused on speed, poor communication. So there was some poor communication between, because if you are developing an application over the infrastructure, then you need to know some basics of the code as well. So for example, if the developers developed the whole application in JavaScript, right? Then the operations team has to have some basic knowledge about the JavaScript, right? Because you are not just deploying the application over the infrastructure. What you are doing is you are also deploying the dependencies, third-party configurations that the developers have used to create the application. All these things had to be deployed over the infrastructure, right? So, so there was some poor communication, and that led to failed deployments, right? Long release cycles, frequent blame games, and I've seen that in the industry. And I've seen that in the industry that the developers had to blame to the operations, and the operations blame to the developers because of the failed deployment, right? So there were some problems. These were some problems before DevOps comes into action. Now, now we have introduced the DevOps thing. Now, what it brings actually? So there is a collaboration between the developers and the operations team. Now it has become a single team now. So if you go to any particular industry, any IT industry, so you will see that the developers and the operation team they sit together. Again, the operation team knows what the developers are doing, and the developers knows what the operations teams are doing actually. So they work as a single team to deploy the whole application on the infrastructure. Now, shared responsibility for build, deploy, and run. So this build, deploy, and run. Now, these are the technical terms that we use to deploy the application. And I will give you some practical example that how can we build and how can we deploy and how can we run the application on the infrastructure. But yeah, the developers and the operations, they together build the whole pipeline. Pipeline is basically what through which your applications deployed over the infrastructure. So you need to build the whole pipeline, and the developers and the operations they both sit together to build the pipeline, and then again they deploy the application with the help of that pipeline, and then they run that application on the infrastructure. So, and automation instead of manual handoffs. Now, in virtualization era, or maybe in 10 to 15 years back, if you remember, everything, the whole deployment thing was a manual work. With the introduction of the DevOps, now this manual handoffs is converted into the automation part. Okay? Now, creating the pipeline to deploy one application on the infrastructure is a automation. That is the automation. So why we are creating the pipeline? We are creating the pipeline to make the things automated. You don't need to manually deploy the application over the infrastructure in DevOps era. What you do is you create the whole pipeline, and then you automate that pipeline, that automatically deploys the application over the infrastructure, on the infrastructure, right? So this is the whole concept of DevOps. I mean, not the whole concept, but yeah, this is the basics of DevOps actually, right? And yes, of course, continuous feedback between development and operations. So, for example, you launched the beta version, the first version of your application, right? And after 1 month and after 2 months, you again relaunch the second version of the application. Now, you don't need to manually deploy the second version of application. What you do is you created the pipeline, you execute that pipeline to install or to deploy the second version of the application on the infrastructure. And this is what we do in the IT industries actually, right? So yeah, so this is so DevOps is not a technical thing, perhaps I should say. It's like a mindset. It's like a mindset that collaborate the developers with the operations team, and then they sit together and then they automate the things to deploy the application on the infrastructure. So this is the tagline for the DevOps actually, that you build it, you run it, right? Now, now I told you about that we create a pipeline in the DevOps thing, right? To deploy the application, we create the pipeline, and the name of the pipeline is CI/CD. So this is the pipeline that we create, right? CI means continuous integration, that you continuously integrate the patches or the the advancement, the advanced features with the infrastructure, and then continuous delivery, continuous integration, and then continuous delivery. So this is the pipeline that we create for every application to deploy it over the infrastructure, right? So what were the problems before CI/CD, before coming to the CI/CD introduction? Now, the code was merged after weeks or months, right? Now, not one developer works on creating the application. Like for example, if there are 4 or 5 developers work together to create an application, so so at at the threshold point, you need to collaborate each and everyone's code at one platform, right? And then there was some problem before CI/CD pipeline, that merging the code of different developers at one platform, it was a problem, right? It was really a problem actually. Manual testing, right? Now, before deploying your application over the internet, what you do is you do some manual testing, you do some testing, you test your applications with different inputs. And this was the manual testing actually. So you had to manually test each and every input, each and every router, each and every features of your application manually. And it takes a lot of time. And that is why it becomes the long release cycles and fear of deploying changes. Okay. And now, after CI/CD introduction, when we started creating the pipeline, CI/CD pipeline, now what were the benefits of it? Continuous integration. It means every code change, whatever you make some changes in your code, is automatically built and tested, and bugs are detected early. Okay, how do we create the whole pipeline? I will give you one example in the later slides, that every code, whatever you make some changes in the code, it will be automatically built and tested as well. And then you can detect the bugs before deploying it over the internet. So this is the continuous integration. Now, continuous delivery is basically what? Code is automatically prepared to production, right? And production. Now, there are two kinds of servers, right? There are two kinds of server. One is the development server, and second one is the production server, right? So once you create your whole application, right? So before deploying it to the production server, you test it in the development server, right? You test that particular application in the development server. Now, once all the tests are passed, then you deploy the application in the production server, right? So this is the concept of the continuous delivery, that the code is automatically being tested in the development server. And then once the tested are passed, then it will be automatically deployed in the production server. And this is the standard format in each and every IT company that they follow actually, right? They create some application, the developers design some applications, and then the operations, they create a pipeline, and then they deploy the whole application in the development server where the testing is being done. Then once all the tests are passed, then that particular application will be deployed to the production server. So this is what CI/CD brought to you actually, and this is the whole concept of the CI/CD pipeline actually. So you push code changes, how you push the code, and then you test that particular code, then you build the image of that particular code, then you store that image in the repository, and then from this repository you deploy it to the development and production server. So this is the whole scenario, or perhaps I should say the workflow of the CI/CD pipeline, right? And let me just uh, take some questions if you just give a second. What is okay? Okay, so there's one question between the Afif is that how do automation and CI/CD pipelines improve efficiency in DevOps-driven cloud operations? So, see, the automation is basically is being done by the operations team, right? So what we do is we use some different tools that that test your application, right? So there are some different tools that we can use to test your application, and we integrate those tools in the CI/CD pipeline, right? And I will show you that what are the different kind of tools that we can use, that you can use actually in the pipeline, right? So and that improves the whole efficiency. It improves the whole efficiency by creating by integrating the whole integrating the tools in the CI/CD pipeline that automatically test your applications in different scenarios in different ways, and then once all the tests are passed, then you can deploy your application to the development server or to the production server, so that the everyone can use your application, right? So this is how the CI/CD pipeline improves the efficiency in the cloud operations actually, right? So let's move to the again. Okay, now, so now the next thing is, now once you test your application in the CI/CD pipeline, then what you have to do is you will have to deploy it over the infrastructure. You have to deploy it on the infrastructure. How do you deploy it? Now here the Kubernetes and the containers terms comes into action. Now the question is that we have created the CI/CD pipeline, and we have already tested the whole application, but how do we deploy it on the infrastructure, right? We deploy it with the help of containers and Kubernetes. Now the Kubernetes is basically a tool, orchestration tool, that breaks your applications into different modules, right? And then every module communicate with each and every module, right? So it breaks your application into different modules, and then every module can communicate with each other, right? So this is the basic fundamental of the Kubernetes. Now, the question arises, how do you deploy your whole application in the infrastructure? Now you can deploy it with the help of containers. Now your whole applications is converted into a container, is converted into an image, and that image is being stored in the container. And that container is stored in the Kubernetes cluster. So this is one whole cluster, you can say it. Inside that cluster, we have different containers, and inside that containers, we have the image of your application. And with the help of those images and with the help of those containers, you can communicate with each other. So this is the basic concept of the container and the Kubernetes actually, right? Now, the problem before containers is basically what the applications worked on one machine but failed on another, because every machine has the different configuration, every machine has the different resources. So if one application is working on my machine, it's not necessary that the same application worked on different machines as well, right? So this was the problem, one problem that the developers or the operations team faced actually. And so this is a very famous saying in the DevOps part, that it works on my laptop become a common issue, right? And of course, I told you about that. Every machine has its different operating system, libraries, runtime, and that actually, plays a very important role to deploy your application on the infrastructure. So what we had to do is we needed some common platform that can be used to deploy the application, right? And this is where container comes into action, right? So what we do is we combine the application packages and the dependencies. Dependencies means the third party libraries that we use in our application, right? So we combine all these things into a single container. Container is basically a storage room in general way, if you can say it. So single container is basically what, a storage room in which you have stored your applications, stored your dependencies, stored your all the resources, configurations, and everything. And then with the help of that single container, you can deploy your whole application in the infrastructure. And this is what containers do actually. So containers run the same way on developers laptop, test, and production, because what you need to do is you need to clone the same container in each and every machine, right? So what you do is you created your application, and then you store your applications, dependencies, and everything in a single container. Now if you want to make some changes in the application, what you have to do, you will have to clone that container in your local machine and then do some changes. So what you are doing is you are using the same container, so every developer using the same container, right? So the problem of it works on my laptop now has resolved, right? And it's lightweight and faster than virtual machines. Yes, of course, because it is lightweight. Yeah, this is lightweight. Actually, you don't need to install the extra resources or extra dependencies to work to containers works, right? So that is why the containers now has become a very important part of the cloud computing, right? Now the another part is the Kubernetes. Now we had the applications, we converted them into the container. Now how these containers will be deployed in the cluster? So this is done with the help of Kubernetes, right? Now running one container is easy, running thousands is not. And this is what Kubernetes does actually. Kubernetes automates deployment, scaling, load balancing, and self-healing. So what it does, Kubernetes is like a tool. It creates the whole cluster for you, and inside that cluster, we have different virtual machines. We have different virtual machines, right? And inside those virtual machines, we store these containers, application containers. We deploy those application containers, and then these containers communicate with each other to execute your application, right? So the deployment and the whole thing that I told you about is being automated by Kubernetes. So the deployment of the containers, the scaling of the containers according to the traffic, the load balancing, that which particular container has more traffic, then you have to manage then you have to manage it with the help of load balancing. And in some situations, our containers does not work, right? They failed actually. So Kubernetes actually what it does is Kubernetes restart those containers to work them properly, right? So this is what Kubernetes does nowadays. And so there are some key benefits of the Kubernetes actually, that there is a consistent environment. Yes, of course. So there is only one environment nowadays that can be used by the developers and the operations team as well. Faster deployment because everything is being automated by the Kubernetes as well. So if everything is automated, then there will be a faster deployment of the applications. High availability and auto scaling. Now the auto scaling is being done by Kubernetes, right? So if your application is having huge traffic, right? There's
Pardon,
so
sir?
many. Hello.
Yeah, I'm apologize for disturbing your time for the duration of presentation. Still have around 4 minutes again. Yeah, thank you.
Okay, no problem. I'll just finish as soon as possible. Okay, fine. So let me go to the end. Okay. Okay. So these are some key benefits of using Kubernetes actually, and each and every company is using the Kubernetes to deploy their applications over the internet actually, right? Now, another part is the infrastructure as code. Now, the infrastructure as code, this is the one feature that the Kubernetes provided to each and every company actually. Now, Kubernetes infrastructure as code is basically what you're doing is you are making the whole thing automated, creating the software, creating a particular software, and then creating the CI/CD pipeline, and then creating the image and deploying it to the Kubernetes. The whole thing you can create infrastructure out of it, right? Fine. And this whole service is being provided by the cloud providers, like for example, the AWS, GCP, Microsoft Azure, right? And the tools that you can use to create the infrastructure as code as Terraform, CloudFormation, ARM, Bicep. Um, Specifically, Terraform is the most important tool that we can use to create the IAC. Now this is what we are right now. DevSecOps is basically what the security you have integrated the security in the DevOps part. So the security became a part of development, CI/CD, and operations. So from the starting actually, right, from the development of the applications and creating the CI/CD and then deploying it application in each and every part, you are integrating the security, and this is where this DevSecOps term comes into action. That automated security checks run from the first code commit, developers, security, and ops work together, and this is the DevSecOps practice actually. So what we do is we use secret scanning, we do static testing, we use software configuration analysis, we do image scanning, we do container scanning, and we also do the dynamic testing. So these are the different kind of security checks that we integrate with the pipeline, right? That makes your application secure before deploying it to the production server. And nowadays, now where are we now? Where are we? We are Now, what we are doing is we are integrating the artificial intelligence to the DevOps part. So what we can do is we can write the code, we can write the scripts with the help of AI, we can also generate the CI/CD pipeline, we can create the documentation as well. But what the AI cannot do is it cannot replace the DevOps fundamentals, right? Right. For example, like you can use the AI to create the pipelines, but what if your application, what if your container fails? This is where AI cannot help you out. This is where your basic understanding, your understanding about the Kubernetes, about the DevOps part comes into action actually, right? So yeah, of course we can use the AI in the DevOps field, but not it cannot replace the whole DevOps part. And so I think this is all about from my side, right? And let me take the questions and then we can move forward to just go through that part. Fine. Okay. Now, um, I have already answered the first two questions. So let me just go to the next question. Third question, what role do containers and orchestration tools play in modern? I believe I have already answered that question because with the help of containers, you can create the images of your application and then store it in the container. And then those containers will be stored, will be deployed in the Kubernetes infrastructure to make the whole thing automated, right? So I believe this is all about from my side. Thank you very much for attending this lecture. And yeah, thank you.
Yeah, thank you so much for your time and sharing your knowledge, Professor Abhinav. Yeah, thank you so much. And we will go to the next speaker for Professor Danilo Strugarevic from Alpha Beki University, Serbia. The time is yours. Thank you.
Hello, everyone. I hope you can hear me well. Just a moment to adjust my presentation. Now, see what Microsoft PowerPoint presentation. Okay, can you see the presentation? Okay, thank you, Mr. Kumar, for the wonderful presentation. Can you hear me? Because I'm at the hospital cafeteria. Yeah.
Sure.
Yes.
Thank you.
Yeah, I can.
Yes. Thank you so much for the wonderful presentation, because everything you need to know is based in the previous presentation, so we could talk about my part of presentation, because I won't be talking about technical details. I will be talking about implementation of these technologies nowadays. So it will be we'll be talking about transformation from traditional to the cloud-based electronic knowledge assessment, about data processing and analyzing. And as I see, we are all here from the universities and the colleges, so this will be a familiar topic to talk about. Because nowadays everything is electronic. So over the past few decades, universities have increasingly banning all the digital technologies, not only for the communications among the professors, not only the student support for the on every level, but also on the content delivery and the knowledge assessment. Why is that? Because evolving of the modern technologies can provide all the necessary benefits for us, and not forget the thing that happened to us, the COVID pandemic, that forced us, many of us in worldwide, to adopt modern technologies. Before 2020, not many universities and colleges use this technology. It was, let's say, face-to-face and paper-based acknowledgement between students and the professors. But nowadays, electronic knowledge assessment has been moved from being an experimental thing at the high education to the core component of the large scale examination in almost every institution. We all know that in traditional way of scoring the students is used only to get the score, the outcome of the exam, but electronic testing can generate much more detailed records and interactions, detailed records about the interactions between students and the assessment platforms. And that's what we need to embrace and use it for our learning analytics and much more. There are many types of data that we can obtain by this. Response time on any given question. If a student changes the answers or know the answers. Keystroke dynamics, if you're familiar with something, you will type it more faster than things that you don't know. Mouse movement, the cognitive perception of every person is different. And also we could track eyes where the student is looking, or even track the emotional state during the assessment. We must know both traditional and electronic testing share the same outcome, selecting the answer as correct or incorrect, but neither of them provide us insight into decision-making process. If you are a professor and you have an oral exam with your student, you will see how he reacts. Does the student nervous, or does he know the questions, where his eyes going during the exam? But during the traditional electronic tests on the platforms, you don't have that interaction, and you don't know if the student knows or doesn't know the answer to the question. So, does the result during the knowledge assessment reflect the actual knowledge, or they are merely result of guessing? That is the main question that this technology will help us solve. And that's what we based on. Traditionally, you have a monolithic system that is based on a server you have in a platform you obtain or you made specifically for your university, and that's the primary engine of ensuring delivering the scoring test nowadays. So in that way, this traditional electronic tests are not made for the large scale data processing and advanced analytics. As you can see here on this picture, you see the school I've been working for 20 years. We have a classroom with 20 computers, and only 20 students could solve the best electronic tests based like this, giving the answers to the questions or simply choosing the right or wrong. But if we have a software as a service that could be used both in traditional way and in modern way, where you can calculate the probability of the correct guessing answer, you will have something like this. And that's top tier a program or the software you can use on the traditional monolithic system and service you have at your university. But in that case, you have this system architecture that you have a participant, you have application, you workstation, and you get the end results. You cannot use any other means to track or the emotional state or eye tracking or screen record and get more data, relevant data. So at the end of the test, you will get only the score. but you wouldn't have insight if the student knew the answer to the test, or he merely just guessed the question that was provided to him. But if we use a cloud-based technology, we are open to data processing analytics on a wide scale. Could we collect all the data and have our own analytics in the real time? Yes, cloud computing with all of his essential characteristics: on-demand self-service, broad network access, rapid elasticity, scalability, can give us answer that we need. Did the students know the answer to the question, or he guessed? As you could see this picture, that this is the part of experiment I conducted during my research. When you see a classical electronic assessment test, but I added some features like eye tracking device, mouse tracking, was recorded live video that would get emotional response. But all this data, because of the traditional system, monolithic system, was stored on the server at this institution, will not provide me all the analysis, so it must be, all the data must be perceived afterwards. So collected, analyzed, and then compared to the given result of that. Let's take example. Let's have an example of two characteristics that we could use in a modern way that cloud computing, with all its scalability, power, and efficiency, even cost efficiency, could provide us. Let's say we have a facial expression recognition technology that holds significant potential for application in educational institutions, only to see potential in evaluating students' emotional state during the test. So, in my study, because of the monolithic system, I need to have a record of the student during the exam, get an image, process the image, feature extraction, and then expression classification. So you see the mapped faces were mapped, and then all data was extracted. Cloud computing could change this with sure. Let's take another example. If we have eye track, we could see the inside of what was students' focus on. Was he reading or not reading? Was he just clicking, but not without reading anything? Was he focused on the answer that is correct or the incorrect? A huge behavior of the students could give us insight of the knowledge thing. Does he know, or is he guessing the questions? So system architecture, this probability by using cloud computing, vast resources for nearly on real-time computing analysis, could look something like this. We have participant, and we have all the components needed for the analyzation, like camera, like eye tracking, sensors, EEG perhaps to focus on his emotional state. All these could be sent to the cloud, analyzed in the near real time, and we will have the results, not only the results of the students like this, where we know did he knew or didn't knew, but we could have the results like, did he guess the questions that he knew? And that will give us the wide spread of learning analytics data to know and compare every student knowledge from the beginning to the end of the course. From an architecture perspective, cloud-based solution would be a service-oriented or microservice architecture. So every step, every sensor or every aspect regarding the application, eye tracking, camera, mouse tracking, screen, could be divided in microservices and analyzed. An assessment delivery service responsible for presenting items and recording response, scoring and rules engage, identity and access management service for authentication or authorization. And all these services communicate through well-defined APIs. They are deployed almost immediately in containers, managed application environments, and can be scaled horizontally according to the usage patterns. You see, a central design feature of many cloud architectures is the separation of operational and analytics data layers. So this separation will allow process and outcome data from electronic knowledge assessment to be retained at fully granulated and analyzed without disturbing the performance of live assessment. Because today, you know, they are not today, So today, you know, we could use scalability, not to use, not to get the exams of 20 students they go there, but the full group of 200 students can do this simultaneously, the test. Outgoing data is periodically exported to the analytics data stores, data warehouses, lakes, which are optimized for complex queries and machine learning works. That is the idea for using the cloud-based systems. As you know, in this case that I use, there are a vast range of informations regarding the facial expressions. So you see the data collected in this example was huge and could not be worked on the classical service. So, for example, is it a goal to determine whatever emotional reaction patterns can serve as a basic for categorization partition by performance levels? So you see, by tracking the emotions, the 7 basic emotions like anger, disgust, fear, happiness, sadness, surprise, we could have a potential side did students knew the answer to the questions or the guess. Could the emotional response time show at the beginning show the high information value? That is also something that was used. I'm talking this presentation, and this example is based on my research that was conducted, and for example, to see a range of data that needs to be processed at this research was for only 25 recorded sessions for 25 candidates. It was 748 instances from participants ID, questions ID, test results, time of the response for every question, self-reporting, emotional response data. That's a huge data set. Not going to the statistic details like emotional statistical values that was considered for each question, everything, average, minimum, standard deviation, average 5 seconds or the first 5 seconds to see the emotions. But what about other instances that could be collected and used, like eye tracking, mouse tracking, and screen recording? You see, now, cloud computing provides us much more by allowing us to process all the data. And therefore, moving from the traditional to cloud-based architecture has data processing and analytics for electronic knowledge assessment. Cloud-native design that separates operational data analytic layers could support near real-time monitoring with advanced analysis and machine learning services. And in the future, I think the subject of this experiment I presented to you was will be directed towards the development of the multimodal system that will simultaneously integrate the emotional, cognitive, behavior, and contextual data through the cloud computing, because at this moment, I think that is the only way to analyze all that quite a big data set and give us the real. I'm sorry for the past presentation and past speaking, because as I mentioned, I was not in the good way available. So if any questions, I would like to answer them now. Do you hear me? Yes, I think we have questions. Yeah. In your opinion, how will cloud computing DevOps continue to evolve over the next few years? Yes, in the aspect of this example I present to you, it is not for the knowledge assessment, not the question, did student pass the test, but did he actually know the answers? So is it that his actual knowledge or he's guessing? We are now here presented with the phones. We have, every one of us has a phone, and we have a camera, we have facial detections, we have microphones, even the screen recording. So in the future, the students won't, they are not, will be forced to go to school and give their exams, but combining all these components, they could tell us, we're really sure that that is the student that's logged on the service, that he gave us all the questions without using the AI, and that he will that the outcome and the results will be the expression of their knowledge, but not of their guessing, because as you know, the wide range of tests are based like single choice or multiple choice questions. That's it. Any other question?
I guess no one else asking again, Chair.
Hello.
Yeah,
I don't
I,
think.
I guess no one else asking again.
Yes.
Yeah. Okay. Thank you so much for your presentation and for your sharing your knowledge. And before I close this event, for all participants, please open your camera. I will take a picture on the count of three for documentation. Okay, 1, 2, 3. Yeah, thank you. Thank you for your cooperation. Finally, we come to the end of webinar today. We would like to thank you for all speakers for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to more collaboration in the future. The webinar for today and here. We hope to see you soon. Thank you and have a nice day. Thank you so much, sir, and goodbye.